In this video, I will show you how you can use the online mod solver provided by Professor Manfred Hammer. First, open your web browser, connect to internet, and then go to the website computational-photonics.eu. You will arrive at this page. Just select the first one. This is OMS. Click it and it will give you this page. This is how you define your waveguide: the refractive index and the thickness, the wavelength of the light, and the polarization of the light. You can change the number of interior layers mean this one, whether you only have one layer for 3-layer waveguide, or if you change to 2, you will have 2 layers for the interior layer. Let's say we just have one, so this is just a simple 3-layer waveguide. The lowest one is the substrate. Let's say we have substrate of refractive index of 1.5. We have layer 1 of refractive index of 1.6. And we have cover, let's say water, refractive index of 1.33. And we can define the thickness of the waveguide. Let's say we put it 0.6, so 600 nanometer, a very thin layer of the core layer of waveguide. Here we put the wavelength of the waveguide. Let's say we want to see how the wavelight behaves. What is the modes of the waveguide for wavelength of 1.55, because it is the mostly used wavelength for optical communication. We want to see how it behaves for TE polarized light. Let's solve it. It shows you one mode. We can plot the mode profile of this mode. It will give us this mode profile like this. It is not symmetric because our waveguide itself is not symmetric. Now we want to make this waveguide not only single mode, but let's say multi-mode. So we can change either the index contrast, which is the difference between the refractive index of the core and the substrate. We can increase this one, or we can also increase the thickness of the waveguide, or we can put shorter wavelength light, because by increasing either the index contrast or increasing the thickness or decreasing the wavelength, you will increase the phi number. And remember, phi number will dictate the number of the modes of the waveguide. Now let's start by putting this one to be 2, the thickness of the core layer. We increase it into 2 micrometer, solve it, and now we see we already have 2 modes. If we increase further, let's say put it 5, we will get more modes. So this is how the thickness affects the number of modes. We can also do the same for thickness, the same thickness, but we increase the index contrast. Let's say it's still 1 mode. Let's put it to be 3. It will be multi-mode already. Now it is multi-mode. We can also plot the mode profiles of fundamental mode TE0 or higher order mode, first order mode TE1, or plot them together in one graph by just clicking. We can also see how the pointing factor of the modes looks like. Let's say we want to see the pointing factor SC for mode T0. It will be like this. If we look at T1, it will be like this. We see there is no negative number of pointing factor because pointing factor represent power density or intensity of light. There are no any negative intensity of light. We can do the same for TM polarization, solve it. Let's say put it to 3, solve it, it will give us, this waveguide has 10 modes. We can plot the dispersion curve of this waveguide by doing this menu, scan. We can change any parameter here, either the thickness, the wavelength, the refractive index, and so on. Let's say we only want to change the thickness. So we want to change this one from, let's say, 0.01 until 5. Do it for 100 steps. So we will get a plot of dispersion curve. But this dispersion curve is still in as function and effective as function of thickness. If we want to plot the dispersion curve of function, let's say function of phi number, we have to do that manually. If we click, let's say here, we can see for this thickness, what is the values, in number, the value of N effective. Let's say we do it for thickness of 0.5. We click here, this is the value. You can copy that and put that into an Excel file. Do it for, let's say, 0.6. It will show different value. The red dot in the curve will move to other values. Do the same manually until, let's say, 1, and then 1.2, and so on, until you think it is enough. Let's say until 3. You already have quite a lot of modes. You already copy this into your Excel file for many numbers of modes, and then from the Excel file you can calculate how much is the phi number for corresponding thickness, and wavelength and refractive index of the core and the cladding. You remember the formula for phi number is function of that. So now you already have data of this phi number, what is the modes, the N effective of the modes for, let's say, now is for TM. You can do the same for TE. And by having that data, you can make a plot using, let's say, Microsoft Excel, N effective as function of phi number, as asked in the homework. Okay, I think this concludes my demonstration on how to use the online mode solver, planar mode solver.